we started to design strip footing. Just to remind you, strip footing, we have two cases. The first case, you have a wall with a certain length. This length is known. This length is known. Then the footing length is known. The same length of the wall. Probably you can extend 1 feet and another 1 feet from the two sides or two ends. That's fine. So what will be the width of the footing? This is the first case. So the area of the footing will be this length times this width. That's fine. Second case, we have a wall with infinity length. I cannot know where the start and where is the end. So in this case, we are designing a footing based on unit length. I'm gonna assume unit length 1 feet, and I'm looking for the width, which is B. So the area required for this footing will be 1 feet times B. And also the given load, B dead load and B live load, will be something kept bare foot. If your given load is kept bare foot, that means the wall has infinity length. We are taking only 1 unit length, 1 foot. So unit equal P divide area required. Unit will be, you can figure it out, P equal B dead plus P live without factor. I can figure out the area required. Guys, do you remember after you did the dimension of the footing, we have two issues. We need to check for shear. We need to check for moment. I have, you should learn this information. You should remember it all the time. Where is the critical section for shear? Do you remember that? Here is the wall. Here is the footing. Do you remember where is the critical section for shear? A distance D from the face of the wall. At this location, we have a critical section. So this area, this length, times the unit length, which is feet, 1 feet, I can figure out the value of V ultimate, which equal Q ultimate times this area of shear. We have issue with moment. Just to remind you, do you remember where is the critical section for moment? At the face of the wall. So we have stress here, which called Q ultimate, coming from P ultimate divide area of footing. And I can figure out this length, and the other length is 1 feet. So this area can be figured out. If you multiply this area by this stress, I have a force. If you multiply this force by this half distance, I can get a moment M ultimate. Once you get the M ultimate, I can get the reinforcement. And also here, once you get V ultimate, I can check the depth for against shear. All of this stuff for strip footing. Let's start to talk about isolated footing. Actually, it will be exactly identical procedures. By the way, isolated footing means we have a footing carrying a column, only one column. One column is supported by one footing. At this time, this footing can be called isolated footing, like this one. Like this footing or this footing or this footing. We have few steps, and I will go through these steps and see what is the difference between isolated footing and strip footing. First step, we need to get the total and factored load. P equal dead load reaction plus live load reaction. This one can be called an factored total load. That makes sense. I believe this load will be used with Q net to figure out the area required of the footing. I think the second step, we need to figure out the factored or the ultimate total load. So we need to use factors. We need to use 1.2 for dead, 1.6 for live. This is the second step. Third step, we need to assume the footing depth or the footing thickness, overall depth, HF. Actually, you can assume what you want. 16, 18, 24, 26, 28, 30, that's fine. But for isolated footing, we have some guide. If the column is rectangular column, I can use this expression to help me to figure out a depth. If the column is a circular column, I can use this expression to help me to figure out a depth. I'm talking about this depth. If you can get a depth, add 4 inch to this depth to figure out the total thickness. If you don't like to use these two guides, okay, go ahead and assume your thickness like we did in strip footing. Okay, I will use this equation. So what is the meaning of this equation? 4 depth square plus 2b plus c. B and C are the 2 dimensions of the column. Guys, before designing foundation, you should design the columns. That's right. You already finished this step. You already designed the column. So if the column is a short column, short tied column, P ultimate equal, I think, 0.85 phi 0.85, as I remember, F prime C area gross minus area steel plus F yield time area steel. That's right. So from this equation, I figured out the value of area gross of the column. I figured out the cross section of the column, which is B and C. Right now, we are in another step, in the following step. This column with dimension BC that you figured out before is supported by a footing. So we are right now in this step, designing of footing. So that makes sense. So the previous step was designing the column. The current step is designing of the footing. Okay. So B and C, the 2 dimension of the column, D is the depth, P ultimate is the ultimate load, phi equal 0.75, VC or nu C equal this expression. For lambda equal 1, square root of F prime C. So we have equation from the second order. I can solve it to figure out the depth. If you don't like to assume thickness, once you get this depth, go ahead and I add 4 inch to this depth to get the total thickness of the footing. Okay, so we have a guide here, can help you, bro. This step can help you to figure out the depth. If you don't like, it's up to you. If you don't like to use this equation to help you or to guide you to assume the correct depth, okay, go ahead and assume your own depth. Any question? Oliver, looks like you have a question. No, for strip footing, we don't have this empirical equation or empirical expression. This is only for one column supported by a footing. Okay. The next step, we need to figure out the Q net. As you know, from the geotechnical engineer will give us the allowable bearing capacity. Q allowable is the allowable bearing capacity given by the geotechnical engineer. But this allowable, we need to subtract this weight of footing, which is gamma concrete times thickness of the footing, and make sure that this thickness in feet. Make sure that this thickness in feet, because gamma concrete is 150 pounds per cubic feet. I need to also to subtract this weight of soil. So this depth of soil, which called H soil, HS, this thickness for concrete is HF, footing. So gamma soil times HS. So to figure out the Q net, you need to subtract Q allowable minus gamma soil H soil minus gamma concrete H footing, and make sure this depth of soil in feet. The depth of soil above the concrete surface. Once you figured out the Q net, I can figure out the area of footing. The required area of footing, which is length times width. This area will be P and factored total load from the first step, do you remember? Divide Q net, I can figure out the area required. Guys, if your column is a square column, your footing will be square also. If the column is a rectangle column, your footing will be rectangle. So if your footing is a square, this area under square root, I can figure out the side length of this footing. If this footing is rectangular footing, I'm gonna assume 1 dimension to figure out the second dimension. So I will assume, for example, the width to figure out the length, or I can assume the length to figure out the width. By the way, and that makes sense, if you have a rectangle column like this, I think your footing will be like this. The longer dimension of the footing will parallel to the longer dimension of the column. And the shorter dimension of the footing will parallel to the shorter dimension of the column. And that makes sense. Okay? If your column is square, your footing will be square. That makes sense. Guys, we need all the time to make sure the centroid of the column is the centroid of the footing. The centroid of the column is the centroid of the footing to make sure you have uniform stress on the soil. Okay, so from this step, I can figure out the area of footing. Once you get the area, I can figure out the dimension of the footing. So right now, I figured out the total thickness of the footing. I figured out the dimension of the footing. And that makes sense. Looks like we don't have too much difference between strip footing and isolated footing. Guys, for isolated footing, we have 3 issues. For isolated footing, we have 3 issues we need to check or we need to design. The first issue called punch, or sometimes we can call it two-way shear. The second issue can be called shear, or sometimes one-way shear. The third issue is the moment, and this moment will give you the area steel. Bunch. I told you before something around about bunch. Do you remember when I told you if you have one-way slab and this slab is supported by a column, this column can make bunch in this slab. We are worrying about bunch. Looks like you have a piece of paper and you have a pencil with a sharp end. So we can expect bunching for this paper. The same issue for footing. You have a footing with thickness H footing. This footing is supporting a column. We can expect bunch. Bunch means the column will move this part of the footing to down, and the soil will move the outer bar to up. So we can expect bunch. I believe I have a picture here like this. So this column will push this part of the footing down, and the soil pressure will push the remaining part up. So we can expect bunching like this. This is called two-way shear, or sometimes punching or punch. It's very important. Wow, this phenomena does not exist in strip footing. And that makes sense, I believe, because strip footing, we have a continuous. So how can the punch will happen? Bunching means we have a very sharp or very thin column. I believe this column is thin. 16 inch times 16 inch or 20 inch times 20 inch. We still have one element, one vertical element with a certain dimension. So I expect bunching for this part of the footing. This phenomena does not exist if you have strip footing. We never heard about bunching in strip footing. It's not an issue. So this issue only related to a column supported by a footing. If you have a column, you can expect bunching and also shear. According to ACI, I need to figure out what is the area of the footing will go down with the column. Okay, come to the column dimension, and you have a distance here, depth of the footing divide 2 from this side, and the depth divide 2 from the other side, and the depth divide 2 from this side, and the depth divide 2 from this side. Once you extend your area D divide 2 from each side, I will construct a new area. This area can be called area of bunch. Okay? Area of bunch. We need to figure out what is the perimeter for this area. And what is the area of this area of bunch. So first step, to check the bunch, we need to figure out Q ultimate. Do you remember the value of Q ultimate? Equal P ultimate 1.2 dead load plus 1.6 live load. Divide area of footing. If the footing is a square, so B square. If the footing is rectangle, B times L. So the denominator is area of footing. So the perimeter of the boundaries, outside boundaries for the column dimension, P naught equal this length plus this length plus this length plus this length. If you would like to use this expression, that's fine. C plus D times 2 plus 2 B plus D. D is the depth of the footing. C and B, the 2 dimension of the column. Two dimension of the column. And that makes sense. If you add D plus divide 2 from here and the D divide 2 from here, I believe the total length will be C plus depth. And if you add D divide 2 from this side and the D divide 2 from this side, so the total length here will be B plus depth. If you add this side plus this side plus this side plus this side, so I can add this one times 2 and this one times 2. So I can figure out the perimeter of this area. That makes sense? Looks good. V ultimate bunching force equal P ultimate of the column minus Q ultimate time this area. So from this step, I figured out the perimeter of this area. Second step, I used the value of this area time Q ultimate with minus plus P ultimate, which is the ultimate load. Once you get the ultimate bunching force, I need to check a check of the assumed depth. Most of the time, 99%, we are using this expression only. V ultimate 2 2 means two-way shear. So you are working on bunch. Okay, divide phi 0.75 4 lambda equal 1 square root of f prime c b naught. B naught is the perimeter of the bunching area. I will figure out a depth. This depth must be smaller than or equal the assumed depth, and I hope this expression will be valid, because if not, you have to go back and assume a new depth. The second expression used if you have a rectangular column. So I'm gonna add here beta c, and this beta c must be greater than 2, and beta is the ratio between the long side to the short side of the column. One of you will ask me, hey, if the column is a square, 20 inch and 20 inch, so beta c equal 20 divide 20 equal 1, it's not valid, because beta must be greater than 2. One of you will say, hey, I have a column with dimension 30 and 20. So the longer beta c equals the longer 30 divide 20 equal 1.5. I'm sorry, it's not valid. Beta must be greater than 2. So this expression, it's very rare to use it. Beta must be greater than 2. Not applicable unless beta c greater than 2. What is the value of beta c? Is the ratio of the long side of the column to the short side of the column. The third one, I'm gonna use it if your column at the edge of the footing, or your column at the corner of the footing, and sometimes if your column at the center of the footing. So interior column, edge column, or corner column. And I'm giving you the value of alpha s based on the position of the column. But my recommendation, use only the first expression. But just keep in your mind, we have another different expressions in a different cases. Okay, so I'm telling you, just use the first one only to make it more easy. Any question related to bunching? I need you to understand this point. For a footing supporting a column, we have issue with bunch. Where, a good question, where a distance d divide 2 from the face of the column in each side. D divide 2. Then I will construct a new area. This area can be called area of bunch. I need to get two values, B naught, which is the perimeter of this area, and what is the area value. This area value will help me to figure out V ultimate 2. This P perimeter will help you to check the depth. Any questions so far? Any questions so far? It's a good question. It's a very good question. when you are calculating this value for V ultimate, make sure everything in feet of the dimension. C plus D must be in feet. B plus D must be in feet. Everything in this expression must be in feet. When you are trying to calculate B naught, please, everything in inch. Why? Because B naught will be used here. In this expression, everything in PSI, everything in inch, everything in pound. Okay, so this V ultimate 2 must be in pound. F prime C, PSI, B naught in inch. So this is the reason why I told you this expression must be everything in inch. But make sure this expression everything in feet. Why? Because Q ultimate will be pound per square feet. Q ultimate from this expression. P ultimate divide B square, the area of footing. Area of footing in square feet. So when you multiply Q ultimate by area, this area must be in feet square. So everything here must be in feet. So make sure your units are consistent. By the way, if you are using this expression, everything in PSI, everything in inch, everything in pound. We have also issue with shear. This shear can be called one-way shear. Guys, do you remember from strip footing where is the critical shear location? At distance D from the face of the column. At this distance, I will assume I have critical section here. Can you figure out this area? And then multiply this area by Q ultimate. I can figure out the ultimate shear force. I'll call it V ultimate 1 to make sure we have a difference between V ultimate 2, V ultimate 2 for bunch, V ultimate 1 for shear. These expressions only to help you to figure out what is the length here. Because if you know the length and multiply it by this B, I can figure out this area. Once you get this area, go ahead and multiply it by Q ultimate, which is the ultimate soil stress. I can figure out the V ultimate. To check for depth, I can use this expression, V ultimate B inbound, F prime C in PSI. P web here will be the width of the footing. P web, this width. I hope the depth will be okay, because if not acceptable, we have to increase the thickness of the footing. So right now I did a check against the bunch, which called two-way shear. I did a check against shear, which called one-way shear. Next step, reinforcement. It's very easy. Do you remember where is the critical section for moment? Exactly at the face of the column. Can you figure out this length? I believe you can. And I know this length. If you multiply this one times this one, I can get this area. If you multiply this area by Q ultimate, I can figure out this force. If you multiply this force by this distance, I can figure out the M ultimate. Once you get M ultimate, I can figure out rho, then I can figure out the area T. That's fine? That's fine. And make sure rho within the limit, rho minimum greater than rho minimum and smaller than rho maximum. Let's do one example and see what's going on. I will finish up this example and then we are done for today. Guys, we need to design a square, we have a square column and we need to design a square footing. And the column is 16 times 16 inch. Interior column that supports a dead load and live load. First step, I'm gonna calculate the n factor, the total load. 200 plus 160. 360 kip without factor. Second step, ultimate load 1.2 times depth, 1.6 times life. I should have a calculator. So 1.2 times 200, 1.6 times 160, 496 kip. What do you think? What do you like? Do you like to assume? Do you like to assume the depth or using this expression? It's up to you. Let's use this one. Let's try to use this one. 4d square. 4d square plus 2, I think. B plus C, the 2 dimension of the column, times D. 16 plus 60 plus time D equal P ultimate divide phi VC. So P ultimate, we figured it out. VC equal 4 lambda gas F prime C. And the phi equal 0.75. We have here depth equal P ultimate divide phi VC. VC equal 4 lambda F prime C. That's right. 4 lambda, yes, F prime C, square root F prime C. Let's do this expression. 4 times 1, square root F prime C, 3000. This expression will be 219.1. So this expression will be 4d square plus 64d equal P ultimate 496 times 1000 to be in bound, divide phi 0.75 time VC 219.1. So 4d square plus 64d minus 3018.6 equals 0. Equation from the second order, I think I can solve it. It will be, just a second. The first one will give you 20.6 inch, and the second solution will be negative 336. I think negative is rejected. We don't have depth with negative. So I believe your depth equal 20.6 will be good. So guys, I'm gonna assume HF equal 25 inch. Then your depth will be 25 minus inch minus 4 inch will be 21 inch. 21 will be good. We hope so. We hope so. I still need to check also. This expression just empirical to help you, to guide you. Okay?
Raymond,
Yes.
your depth is 20.6, but you're assuming 25 inches because like what, you're just giving it some room. I mean,
Yeah, because 20
you assume 5 inches more extra.
yes. You can assume 26, you can assume 28, but just please don't go below this number.
Okay, all right.
Okay?
Thank you.
As I told you, this expression is empirical. That means you don't have the right to say, hey, I assumed my depth based on this expression and it's still unsafe. I'm sorry. This equation just empirical to help you, to guide you, no guarantee to give you a good value for depth. No guarantee to give you a safe value for depth. Just to guide you. Okay? Let's do the next step. Step number 4. I need to figure out the value of Q net equal Q allowable minus gamma soil H soil minus gamma concrete H footing. Q allowable is given in this problem. What is the value? Where is the Q allowable? 5,000. It's given 5,000, and make sure this value in pound per square feet. Gamma soil is given. The unit weight of soil 100 pound. H soil. What is the height of the soil? Please make sure the height of the soil is not 5. Guys, the height of the soil not 5. We have excavation at depth 5 feet. Then I will construct my footing with thickness 25 inch. Then I will put the fill. So can you tell me what is the depth of the soil above the footing? Yes, I can. 5 feet minus 25 divide 12. Make sure your units are consistent. 2.9167. 2.91 minus gamma concrete 150. Thickness of the footing is 25 inch. Please divide it by 12 to be in feet. This one in feet. Then I can figure out the value of Q net. It will be 4,396.5 pound per square feet. The next step, area footing will be P and factor the total load, divide Q net. P, go back to the first step. What is the value of P? 360 kips. Kips. And the Q net from this calculation 4,396.5. But this one in pound per square feet. You have to make your units consistent. So I need to multiply this value by 1,000. So the area required will be 81.9 feet square. I need to convert this area footing to square footing. What should I do? Just get the square root of this value probably it will be 9 feet times 9 feet. 9 feet times 9 feet, it's very close. Probably you can assume it 9.1 times 9.1 feet will be better, or 9.2. It's up to you because you are very, very, very close. If you assume that 9 times 9, your area will be 81, but we need 81.9. So I'm gonna, it's very close, can be accepted, but better to assume it 9.1 times 9.1. So this dimension will be 9.1 feet times 9.1 feet. So right now, your total thickness is 25 inch. The actual depth is 21 inch. And the dimension of this footing, 9.1 times 9.1 feet. We need to check. Let's start, but before checking, guys, we need to get the Q ultimate. Q ultimate equal P ultimate divide area of footing. P ultimate, what is the value of P ultimate? I think P ultimate equal 496. Divide 1000. I'm sorry, time 1000 to be bound. We like bound. Divide area of footing, actual area of footing. The actual dimension right now, 9.1 times 9.1. So this value of Q ultimate will be 5,989.6 pound per square feet. Put your units all the time. This area in feet square, this value in pound, so everything in pound. We need to check off bunch. Very easy. Here is the footing. Here is the column. Guys, can you remind me what is the dimension of the column? 16 times 16. From this column, I'm gonna assume distance here, depth divide 2, depth divide 2, depth divide 2, depth divide 2, to assume a new area. And this area can be called area of punch. By the way, can you tell me what is the total length here? Can you tell me what is the total length here? In inch. What is the total length? 16, the length of the column, plus 21. We have depth divide 2 from this side and the depth divide 2 from this side. That means we have depth. And this length is 16 plus 21. So 16 plus 21, 37 inch and 37 inch. What is the perimeter B node? 37 times 4. We have 4 sides. 148 inch. What is the value of V ultimate 2 equal P ultimate minus Q ultimate time this area. P ultimate 496 times 1000 to be in pound minus Q ultimate, just you calculated it, 5,989.6 time the value of this area, 37 times 37. This length times this length. But 37 in inch, 37 in inch, I will divide it by 12. Why? To convert it to feet. Why? Because this Q ultimate is bound per feet square. If you multiply pound per feet square times feet square, your value will be in pound. I can subtract it from this value, which is in pound. So your final value of V ultimate 2 will be 4,300 or 43,900. No, 439,057.2 pound. Okay, we need to check of the depth. Do you remember the value to check? I'm gonna use the first expression, V ultimate 2 divide phi 4 lambda. V ultimate 2 divide phi 4 lambda square root F prime C times B naught. Go ahead and put your numbers. V ultimate 2 phi 0.75, 4 lambda is 1 square root of 3000 times B naught. The perimeter of this area 148. Make sure 148 outside the square root. So what is the value of depth? I hope the value will be good. Here you go, 18.1 inch. What did you assume? Wow, we are good. This is for bunch. We need to check step number 8. Check of shear or one-way shear. Just to remind you, we have a footing and here is a column. Guys, this total length is 9.1 feet. This length of the column 16 inch. I'm gonna draw a distance equal D, which is 21 inch. I have a critical section here. Can you tell me, by the way, before telling me, this length for the footing is 9.1 feet. Can you tell me what is the length for this area? Be careful. I need answer. I need one to help me to figure out this length. I'm looking for what is the length here. Any answer? Guys, any answer? Hmm. 25. Burak, this length, this total length is 9.1. You are kidding me. That means this length is 25. Oh my goodness. No, it's not 2.56. No. Guys, I give you a hint last meeting to help you to figure out these distances because it's very critical. It's confused. No, Brian, no. Okay. So, guys, what is the distance between this center line and the edge? 9.1 divided 2. 4.55. From this length, please subtract 8 inch and the 21 inch. Please convert them to feet. 8 inch, yes, 8 inch you are talking about half of the column. So 8 inch plus 21 inch divide 12, subtract it from 4.55. This length will be 2.13 feet. If you would like to get the V ultimate one, will be Q ultimate time this area. The value of Q ultimate 5,989 time this area 2.13 time 9.1. This value will be 116,266 pounds. Can you check? Please go ahead and check for depth due to shear. It's very easy. You can check it and it will be okay also. Thank you, Nancy. Thank you. Number 9, moment, which is the last step. Moment. For me, as an instructor, I would like to draw the footing and the column every step. Do you remember what is the critical, where is the critical location for moment? At the face of the column. So can you tell me what is the length here right now? This one is more easy. Any answer? Thank you, Nancy. Second time. 3.88. The same also. I'm using the same meaning from the center line of the footing. This length is 9.1 divided 2, which is 4.55. Subtract this little distance, which is 8 inch. Make sure you convert it to feet. I can figure out this length. So we have area. Do you like to get the force on this area? Will be Q ultimate time this area. The value of Q ultimate was 5,989 time this area 3.88 time 9.1. If M ultimate will be this force time this half distance, which is 3.88 divided 2. Will be 41,0584 pound foot. Can I figure out M ultimate divide phi B D square? By the way, this depth is 21. This B is 9.1 feet times 12. The width of the footing is 9.1 feet. So I converted it to inch. Phi 0.9, M ultimate, please multiply it by 12 to be in pound inch. Then I can figure out rho, check between rho minimum and rho maximum. Then I can get the area steel.